Thanks for coming. We're happy to see you. We wanted to talk to you today about what Google does to queries, partially because we started talking about similar topics and we both got really excited about them.
Yeah. So, my name is Koray. I'm the owner and founder of Holistic SEO and Digital, and until now I have written actually 7 publicly published SEO case studies that are longer than 2,000 words, not 2,000, 200,000 words. And after I do it, it became a kind of popular, actually thanks to Rebecca, because whatever I write, it's a bit machine-friendly rather than human-friendly, and Rebecca knows how to turn them into a human-friendly way. So in this session, if I a little bit get you confused, sorry for that, but I believe Rebecca
I'll
will
attempt to make things sound a little bit clearer. We'll see how that works.
Okay.
So you might remember back in like 2010, when Google looked something like this. You entered a text, you press enter, and you found the web pages that contained that text. That was essentially how things worked. So your keyword is your query.
Okay.
How do we know that?
So in this context, actually, when you look at the Google, you will actually see a hybrid search engine. It started as a hypertextual search engine that focused on the links. Then we have started to focus on these type of regular strings without any kind of feeling, context, just letters to letters. But later, it started to change, as Rebecca said.
Go ahead. So one of the reasons that we do know that we started out with text queries and text in content is stuff like this. Now, before I get into this slide, a quick PSA. A lot of our slides look something like this. They're a little complex, and they might look a little scary. If this is not what you're used to looking at, it's okay. We'll tell you what you're looking at, why we put it up there, and what we want you to take from it. Also, if you are not a big fan of reading academic journals or patents, that's okay. Your job is to take the information that we've stuck up here and stick it in your SEO strategy, and that's where you win. Here what you're looking at is a journal paper from Sergey Brin and Larry Page in 1998, in which they're talking about a new way of looking things up in a corpus, like a web corpus. And what they're actually saying is they're using pattern recognition. They're looking for titles and authors of books. And so they're using a sort of pattern to do that. And within that pattern, a tuple, they are using regex, which is what you see here on the right. Basically, they're looking for something that a machine can identify as an author name and a title name. So they're matching a string of text in a query to a string of text on a page. And this, at that time, was seen as really, really advanced.
Yes, it was actually really hard on that time because even the Tim Berners-Lee didn't talk about the semantic web yet. And there's a famous article in the Scientific American about the semantic web. I recommend you to check it. And here actually they try to create a kind of tuple, a book and an author. But later Larry Page realized that some of the books are fake, some of the authors are typed wrong. So basically they were trying to create a kind of knowledge graph, but lots of crap also was there too.
So, one of the types of things that didn't come out quite the way Google expected was the fact that we make a lot of errors when we search for things. So pretty quickly, instead of matching exact text to exact pages, they needed to adjust their algorithm. So this is an excerpt from a website, and I'm blanking on the name, which is why I have my cards here, by Peter Norwig, who is the Director of Research at Google, explaining what they do to correct for spelling errors. So even very early, this was pre-2007, they're correcting for problems in the query text. So we're no longer doing exact text to exact text matching. We're doing fuzzy matching. So this is where, if you're familiar with the Lumenstein distance and that type of thing, where you're looking for things that are almost the same. Not quite, but almost.
Yeah, there are actually multiple different similarity algorithms. Lumenstein is one of them. There is also edit distance bias. Imagine that there are two words and you try to measure the distance between these words by changing numbers one by one, and they try to understand which is the cheapest way rather than which is the most quality way. Usually it's Google's perspective, which one is cheaper. If it's cheap enough, they will usually implement it.
So remember, we were talking about like 2010. This is our before scenario. What did SEO used to look like then? There were a couple pretty symptomatic things in SEO then. First of all, you found keywords everywhere. We stuck them wherever we could. And actually, one of my first SEO-related jobs was a copywriting job in which I was told to put a multi-word keyword 4 to 7% on that page. It was a 300-word page, so this was a pretty dense keyword. We saw it in headings, we saw it in titles, we saw it in the text, and we saw it in these big white blocks at the bottom with white on white text. We also saw typos. So over here, you're looking at a 2008 search result where people actually ranked for misspelled words. And on this side, we're looking at a tool which I think was retired in 2014 that actually generated misspellings for your SEO keywords.
Yeah. So when you look at the actual information retrieval, you should memorize the name of the Prabhakar Raghavan, because he is already a really important person in the Google, but also he is really important for information retrieval too. And he even has a book about it, and in this book he talks about these type of string errors, but also he talks about the zones in information retrieval. So in this context here, actually, they try to create all of the probabilities in terms of typing errors. And it is one of the common errors to overcome for the semantic search engines, or any kind of search engine basically.
So fortunately, that's not how things work anymore. Since then, Google has matured, we've matured, fortunately. So things have been different. Most of this has come from major core algorithm updates. So you'll recognize the Panda from 2011, Hummingbird in 2013, where they started really looking at getting rid of web spam, getting rid of people who overloaded keywords, and more looking at queries and how to interpret them correctly.
Yeah, I even know some SEOs can't like the pandas because of the Panda update. I guess
I like pandas.
Yeah, I do too, but for instance, if you are old enough to see the update, it's on target.
So what happens now when you type in a search query? Even before you press enter, there's a lot of stuff going on. So we'll talk about some of those things. We'll talk about parsing, rewriting, context,
and also term-weight calculation in the queries and many other things.
So let's take a look at all that. So first we'll start with parsing. Well, basically, I think most of you are probably familiar with what parsing is in general. It's basically taking a closer look at what are the constituent parts of a query. This is from a patent by Peter Haag. And what you can see there is one of the first things that happens is the query parser. You receive a query, and we're going to look at what are the elements in that query. This is going to help us understand things like, this is an actual search I did, I'm a little like crazy, so when I look for BSC threads, it knows that thread is a word that can have different forms. And so you can see that the results have those different forms in them.
Yeah. And in this one, there is one important concept here. It says query expander. Later, they will start to mention this thing as query augmentation to increase the contextual zone of a query so that they can actually match more documents. If they're able to match more documents, again, it will be cheaper.
So the idea here, as Koray starts talking about, is that we want to be able to rewrite a query, or Google wants to be able to rewrite a query to make it easier to understand and to find the things that best match what the user wants. So over here on this is my right, but it's going to be your left, this is a patent called Selecting Content Using Query-Independent Scores of Query Segments. A query segment is essentially a way of breaking a query up into a section of one or more words that allows it to determine which part of the query is most important.
Yeah. So when you look at a query, actually, there are different types of words for Google here, like functional words, concrete words, and when you choose an anchor segment, they start to rewrite the possible probabilities. One of the important things here is there are two different query refinement methodologies, like end-string refinements and middle-string or mid-string refinements. Most of them here, they're actually mid-string refinements.
So once we have some of the ideas of what part of the keyword is important, we're going to group them. We can see on the side over here, this is a system and method for providing search query refinements, which is also by Peter Haar and I believe it's Stephen Baker as well, where we have some clustering going on at the bottom here. Clustering, the idea behind that is to figure out from the segments what elements can be interchanged, how can we score those, and how can we group them because of their meaning.
Yeah, so at the actual left side you see a word-to-vec model which has been found again by Google, Thomas Mikalo. And here actually we use continuous bag of words and also skipgrams to create some types of clusters, but actually all of these things are different types of contextual zones. When you click one of them, it lies other connected contextual zones. So they try to understand what is the context of query, but also the document. Actually, this document is from David C. Tyler, and he tries to work on the document representation. Imagine that there are 10,000 words and you want to represent them with a single word. So they try to understand how to compress things again, so that you can achieve.
This is one of our favorite sections, keywords to questions. Actually, you can see this a lot with people also ask. This is an excerpt from a paper on people also ask. And the idea behind transforming something into a question has two purposes. One, it's easier for information retrieval. And two, it is much easier to compare questions to find out whether or not they are semantically equivalent, whether or not they mean the same thing, compared to if you're trying to compare phrases. Why? Because questions that mean the same thing have the same answer. So the issue here is Google really wants to, particularly for rare queries, find as quickly as possible the equivalent question in order to be able to answer that as fast as possible.
So basically when you type a query, actually it is about ranking documents according to the questions. And in this context, actually we are talking about a little bit information extraction too, not just a retrieval, because you will need to generate lots of questions and you will need to match all of them with the answers. If they are matching together in a really good way, it means that the efficiency will be...
So this is why when I ask a query like weather today, I get questions that don't necessarily have either weather or today in the answer, or in the questions that are generated. We also use Google also uses question templates. A template is pretty much what it sounds like. These are queries that Google has pre-understood, but the key element can be switched in and out. So this might be a question like, what is the weather in Brighton? But I can exchange Brighton for London, or Brighton for Bordeaux, or Istanbul. But Google has already understood that question because it's using a template for it. Which means that if I add a city that Google has never heard of or never seen before, it knows what kind of answer I want. It knows what kind of information it needs to provide me in the SERP. It just has to look for that particular city.
Yeah. If you want to create a kind of semantic content network, you can actually focus on a single query template or question template. Then you can create a kind of intent template, and you can also create a document template for that. It actually decreases the cost of content production.
We can also see different ways that queries are actually completely changed. Here, this is actually from a patent that Koray referenced earlier. This is generating mid-string query refinements. And basically, depending on where we place the cursor, it's going to replace completely some of the ideas by what it thinks it can add or change in that location.
And as I say, for instance, the word for there, or the word on, and some others, they're actually called as functional words. They create more contextual zones, or possible contextual zones, and in semantic SEO, you usually cover all these things to be able to rank better. So
the next thing that Google does to a query is that it adds context. So these are things that are not in what you typed. These are not present. These are elements about user behavior and user interaction. This example on the left also comes from the keywords to questions. What we're looking at is a query on the right-hand side of that, generating questions on the left, and all of the little boxes on the circles on the outside of this box are elements of search intent that inform the question that is generated. For example, if I look up sushi, which is pretty ambiguous, in Bordeaux at lunchtime, it's going to provide me first at the top of the SERP with a bunch of ideas of where I can eat sushi. If I scroll down, then I get into the definitions. What is sushi? So location and time are both taken into account explicitly. Google will state very clearly in some of their patents and papers that they do use both location and time as parts of ways to define a query. For example, if I look for match Manchester from Bordeaux in France, I get the correct times, so the next appropriate matches, but I also get my top stories in French, because it knows where I am.
Yeah, this section is also a little bit about context-sensitive ranking. According to Google, actually, there are three different contexts. One is the user context, query context, and device context. When you unite all of them, you will have this kind of a combination.
This is where we really get into some of the NLP. So that last slide was Jacob Yuskowitz, who mostly works on transformers now, if you're familiar with that. And if we're talking about transformers, we can also talk about BERT. The idea here is that in order to understand a query, we really need to be in a question-answer mindset. So this is an addition that we saw since 2018, where we can see that if I look up recipe for butter free, that free there is taking into account the entire query, and we know that we're not looking for something that doesn't cost anything. We're looking for something that has no butter.
Yeah.
This is from the candidate passage
answers. It actually belongs to Nitin Gupta and Stephen Lee Baker. Basically, when you ask a question like how far the moon is away from the planet, basically there are three different answers for this question here, and search engine tries to rank the questions according to their quality. For example, one of the methodologies looks on to the coverage ratio. If the words are mutual, they assume that the answer is better, but the information might be wrong, or there are some other things, of course, you could like name and recognition.
So we can see in this one, this is the scoring candidate answer. So this is a patent that has been released, I forget when the actual date was, but it was revised then in 2018 and 2019. So we see that it has evolved from just weighting candidate elements to actually scoring them and choosing the right ones.
Yeah. So whenever they actually expand a kind of patent, it shows that Google actually cares about it, because they try to keep the legal ownership of the document. And in this one, actually, they have focused on the topical entries to understand which section the question actually belongs to.
So the process of selecting an actual answer goes through different stages. And one of the things that is very interesting is that this is where we get a lot of the SERP features that intervene. So you can see that when I look for a dictionary, I'm getting features that answer that query, that answer that search intent, even before I'm looking at what I might end up with SEO. So that's a little complex. Let's take a step back, take a breather for a second. Okay, there's a lot of stuff we didn't actually cover there. I didn't say anything about GNOME. Koray mentioned information retrieval and cost optimization, but we didn't really talk about them. We mentioned some of the SERP features, but we haven't gone into detail about why they picked them or where they come from. And we haven't talked about neural matching. But this all still points to one thing. Google is not using the text in that search box to match it to your pages today. What does that mean? It means that SEO is changing. It's not what it used to be.
Yeah.
Why? Well, some of those old strategies, sticking keywords everywhere, using synonyms even, or assuming that a page that you've optimized is going to really rank, even if your website has nothing to do with that particular page, those only work by accident now. When I say by accident, I mean, if you make a page with a keyword throughout it, if you do that conscientiously, it will naturally be about that subject. You can rank for that, but it's not looking forward, and it's not providing Google with what Google needs in order to really rank that page. What can we do instead? We have a couple suggestions here.
Yeah, so in terms of topical relevance, first of all, it is a different thing than the authority. You can be a kind of relevant to a topic, but it doesn't mean that actually you are an authority in the topic. Another thing is that to be able to understand the topical relevance, you will need to actually understand the semantic distance between the things and also the semantic similarity. Something might be similar to something, but it doesn't mean that they're actually that much relevant too. When you see that you're actually losing traffic after a broad core algorithm update, it means that actually Google changed all of the semantic distances between the words, and they start to create different types of clusters. So in this context, providing the relevance in semantic search is not that easy like before.
remember that neural matching exists. This has existed for a while now. This is Danny Sullivan's tweet from 2018. But this also means that the keywords, the words in that query are not in the web pages. We're finding things that are related through entities, through knowledge graphs, and through semantics. Group your targeted queries. This is an example of that from Stefan Neufischer, who's using Python to look at all of the semantically related queries that can be targeted at the same time. And you will need to cover that entire space if you really want to be at the top of the
Yes, basically if you want to rank for some of these things, you will need to rank for another one too. If you track also SERP features, you will see that these things change together. That's why we call them actually semantically relevant as well.
And most importantly, pretty much what underlies all of this is think about search intent. As Adriana was saying earlier, we've seen so much work from a lot of really talented SEOs on how to integrate search intent. So go look at things by Joanna Meyer, by Lydia Infante, by Lazarina Stoy. So does this work? We're a little ahead of the game, but yes, it works already. Semantic SEO is here.
Yeah. And by the way, I love Bill Slutsky. He's a great guy. Just follow him.
So Koray is also good proof that this works. He mentioned earlier some of his case studies.
When you put 200,000 words together, slowly they start to prove a couple of points. And this is one of the example projects here that I have created, and I started to train some people, and I tried to give some examples for the semantic content networks. This is just one of them, but there are 12 other website samples with every kind of detail. You can check all of them. And these are some of the example results here. They are all from different case studies. Actually, you can check Oncrawl blog, I am writing there. And there are some other articles with even in-links and also some other places as well. So in all of these projects, actually, we are creating a kind of semantically relevant content network to increase the possible rankings.
So basically what that means is your keywords are no longer strings of text. They're sort of a mask for search intent. And I think we're really going to need to find a new way to think about them, to research them, and to put them into place.
And I know that in SEO field, everyone wants to be a kind of millionaire. So if you want to be a millionaire, just try to learn it with semantic SEO. And I don't want to say something bad about Google here because I see that John Deere is just at the corner. So in this context, let's love the Google, and it is one of the best search engines for at least the next 10 years. We will see later what happens. And
so, thank you very much.
Thank you for